now use this form to find the uh, x-intercept. You actually can use either form to find it.
Um, sorry, the x-intercept you said?
Yeah, the x-intercept is the next thing to find, even though it talks about end behavior. Well, you'll get to that, but that's
Uh,
from the graph. Okay. Um, that's
okay.
setting the numerator equal to zero, the top equal to zero.
So, uh, 7/2.
You have to solve for x. Just be careful with some signs there. Your answer is not quite right.
So for x-intercept,
You're literally
like
setting
I can
two
just
x
take
plus
2x
seven.
equals 0.
Yes, just like you
2x,
did the denominator.
x equals. Okay, so my question is, it's positive 7/2, correct? Not as the final answer, but because both of them are negatives brought over, making them positive.
You're just solving for x, like moving the 7 over, then you divide by 2.
Oh, okay, divided by +2. Yeah, so minus
Yeah,
7 divided by 2.
yeah.
Um, that's like, I guess I'll solve that real quick. 7. Like I don't know, 2.8 or something.
You're dividing by 2, so it's between 3 -3 and -4. So -3.5.
Okay, I actually just do not understand how I did not get that.
Okay,
Yeah,
it's
minus
okay.
3.5.
Not
I don't know.
important.
I don't even know what I did to not get that.
That's okay. The y-intercept is putting a 0 in for x. Okay, so it's 2 times 0 plus 7 on top, 0 plus 2 on the bottom. You
Oh,
get another chance to prove that you understand how to divide by 2. It's
2
cutting in
times 0
half.
plus 7, 0 plus 2, and then we're gonna get 3.5 for this one.
X equals, yeah, so it's 0 comma 7 halves. All right, now I really like to graph as you go. Um, and I would have liked us to put some of the stuff in the graph already.
Uh-huh.
Um, like I don't want you to wait until the end. Like we should have graphed the vertical asymptote. The vertical asymptote is x equals -2. Like we should have done that right away. And so I
Alright.
want you to stop here and start graphing in some of the stuff. I believe we got y equals 2 for the horizontal. Make sure you put the equations on the graph.
Um,
You got an x-intercept at
y
minus
equals
3.5 and a y-intercept at 3.5.
so minus 3.5 and positive 3.5. So then, are those all the points I need to put on the graph before I make the lines?
It would be for me. I'm sort of like, if you're going to do it by hand, we're not going to make you go crazy. We're just got to make
Yeah,
it look right.
I
But I'm
think
not
that's
your
enough
teacher.
these days.
I'm actually very like liberal in this sense. Yeah, I don't know if that's good or bad. It's because like if we're gonna do it exactly, we're gonna let a computer do it because computers don't make mistakes and humans do.
Yeah.
So, but that's a different class. It's philosophy. Um,
Uh-huh. So I guess just with that graphing, just it doesn't need to be super, super exact. Just make sure the curve is kind of right on the point.
well, that's where in the next one, or if you want another example, we're gonna graph as you go, and you're gonna see that I do it a little bit differently. We're gonna put in some arrows. We're gonna sort of like figure out where the lines go.
Uh-huh.
But you basically, it's like, well, how do I go through this point, but not like cross these dashed lines? It's like you can't connect this point and that point. You can't come up from down here. There's just sort of some things that you cannot do. You generally cannot cross horizontal and vertical asymptotes. And from the parent function, it generally looks like that. And then if it's a negative, it will switch quadrants as well.
Uh-huh. So those graphs, so they're always opposite, correct?
Yes, they're always sort of diagonal for now. I mean, there could be an
Uh-huh.
exception.
Okay, so I have might actually be on the other side of that paper. I was doing problem number 1, I believe, and the coordinate was -1 and 0 and -2, which made both of the problems be in the bottom left corner of the graph, and then I was told to, like,
That's
reflect
possible.
it over.
Yeah, that's possible.
So, how does the, reflection work in that sense?
It's over the asymptotes. Like think of the asymptotes as like there's a new origin. This is a good question. Most people aren't asking me this. So like think of that as your new origin.
Uh-huh.
So it's always going to like they shift it sort of left, right, up, down based on the horizontal asymptotes. It's
So where
always
those 2 lines meet is my new, like,
yes,
0, 0 in a sense,
exactly. Yeah,
and
exactly.
then I'll make the dots, like, the same distance from one another.
More or less. Yeah.
Okay. Alright, that's not too bad.
Okay. Do you want us to do the next problem or do you have some other uh,
Um,
things?
yeah, let's do, problem number 4.
Okay. So this time we're going to graph as you go. We're not going to wait until the end. Um, all right. So can you tell me the vertical asymptote when it's in this form, or do you just want to immediately convert it to the single fraction form? I'm okay with
Um,
either.
I'll just convert it just so it's, like, that's out of the way.
Okay. Go ahead and do that, please.
So, vertical asymptote would be,
Well, hang
uh
on. You said you're going to convert it to single fractions. Give me the numerator.
I got -4x minus 5 over x
Oh,
plus
good.
1.
That's really good. Okay. Now, vertical asymptote is at what?
It would be +4.
You're setting the bottom equal to 0.
Oh, sorry. Wait, then how did I get okay, I don't know where I got the 4 from. Yeah, it would be +1. No, -1. X plus 1 equals 0. X equals -1.
Okay. Now, here's where it's a little bit different. What I'm going to do is put some arrows. And so at the top and the bottom, and the idea is that the curve is either going to connect on that arrow or the one on the right of it or the one down here.
So
It's
that's
gonna,
just showing which way the line's moving.
yeah, we don't know yet, but it's like we will connect these at some point. So now the can you give me the horizontal asymptote?
Um, that would be -4.
Okay, so similarly, go down here and grab 1, 2, 3, 4. Y equals -4. And you'll again see that I generally put these arrows in because it's going to
Oh,
connect. Okay. It's going to connect to one of them. And we'll maybe see that here in the next thing that we do. Um, all right. So could you find the intercept for us, please?
yeah. Okay, x equals 5/4, which is one and a
Nope,
half, correct?
nope, nope. Get a sign error.
Sign error. Minus 4x minus 5 equals 0, minus 4 divided by minus. Oh, 5 over minus 4?
Or -5/4.
Negative 5 over 4. Is that because when it gets brought over, the denominator can't be a negative?
The negative actually goes up to the top. I mean, it can be negative, it just looks weird, but you just bring it up.
Oh. Okay.
Okay,
So then,
so now, good.
oh, sorry. Would that be a negative one and a half?
It's -1 and 1. I mean, it's -1 and 1/4.
Negative one. Uh, 0.14. I don't know how to. How would I
It's
properly? I don't know why I can't remember. How would I write that properly, like in the zero format?
this is fine. -5/4 is fine. You just have to know that it's between -1 and -2.
Okay.
Like, you don't need to do that.
Okay, sounds good.
All right, so now we've kind of got some answers here. Like, how can you get to this point, the one you just gave me, the x-intercept, without crossing the vertical axis and horizontal axis? Well, it has to be this one. There's no other way to get to it. Like, you can't go from this arrow on the bottom because then you're crossing the horizontal. You can't go from this one because you're crossing the vertical. Like, that's the only one.
Uh-huh. So, and it just stays in that top left box from minus 1 and a fourth.
Yep. Now let's have you find the y-intercept, please.
All right. So all of them become 0. So minus 5 over 1 equals -5. So then it would be 0, -5.
So
Write that
it's
in.
kind of the same idea. It's like, how do you go through that point without, crossing? It has to be that one, that graph.
All right. The I actually did just randomly remember something that I had note wise about. I have a quiz on this tomorrow. I'm not really stressed about it just because this isn't too hard. But someone mentioned something about the problem actually being a little bit different than these, even though this
That
is
that
our
that
study
would make
guide.
sense.
Yeah, which I don't get. They said it's one. So this is like the just like raw f of
Yeah.
x
Yep.
equals positive 1 over x plus 1.
Like this.
No, no, like the plus one's like by itself.
I see.
So it's not a denominator.
Like that.
Yeah, like that. That's what I heard
Okay.
that the problem is, but
All right. Yeah, this actually is easier than what you've been seeing. It's just that maybe what can happen is you get into the pattern of doing a certain way and you're like, okay. Uh,
you're just used to the extra steps.
yeah, so let's just do the same thing we've been doing. Make it into one fraction. So what do you multiply the
Uh,
top and bottom by?
I mean, 1, I guess.
Nope. Why did you multiply?
Oh, by x. By x.
Yes, there you go. There you
Okay.
go.
So, I don't know. I saw that you wrote the 1 there, so then I was like, I mean, maybe it is 1. Yeah, so then that's
Do the same thing you've been doing. Just like what I'm trying to get you to like what the way that I show you problems is you do the same steps. So you're going to multiply top and bottom by something. You have to figure out what that something is.
um
And you just did it.
okay, sweet. So I guess my question is that just x plus 1 and x plus 1?
No,
No, x plus x, so 2x?
here's what it is. Okay. And then if I'm going to draw an analogy, 1/3 plus x over 3, the bottom stays the same. because
Um,
that's the rule. Like we don't question that. That's the rules we play by. The top, though, you just add them.
mm, okay. So then that would just be 1 plus x over x.
Be 1 plus x over x. Yeah.
Okay, so 1 plus x over x. So then, okay, the only reason why this is just like not clicking super well, I guess, is because I'm just thinking about
Okay, here, let's make it, let's do this. X plus 0. Let's go back to the original. If it's x plus 0 and you multiply by x plus 0, x plus 0, does that make it better?
yeah, I guess that does make it better.
Okay.
So then,
That's okay. Yeah, that's fine. If that's what it takes, like you're allowed to do that. It's just you don't need to, but you can.
uh, so then would that make the like end behavior just be 0?
We're gonna
Horizontal
get to that.
asymptote?
We're gonna get to that. Like the all we're gonna do everything we just did. You have to now find the vertical asymptote. And this is where it's better if you learn the rules. Like, what did we say that you do to find the vertical asymptote?
What I do is I look at the last number
No, you
as
set the
like,
bottom equal to 0.
oh, oh, sorry. I was thinking of end behavior guide. Yeah, so you'd set the number to 0, but
You set the bottom equal to 0, and then you'd
x
solve for x.
0, so it just stays 0, I believe, right? There's no number.
Yeah, that's it. That's your vertical asymptote. So now when you go to graph this, you have to graph it right there. So there's x equals 0 right there.
I can't see it unfortunately.
You're not seeing my screen?
Like are you making a graph right now?
Well, yeah, it's just this line right here down the middle.
Yeah, I can't see it. I only see the VA dot dot x equals 0 or colon.
Okay, let me stop sharing.
I think it just froze or something.
Okay, so I'm resharing again. How is that?
Currently it's a black screen, but I can just leave the meet and rejoin if you want me to.
That might be the best thing. Yeah.
Okay, yeah, I'll just do that real quick.
Okay.
All right.
So we've got a graph on the right here. Hopefully you're seeing that now.
Yeah, I see that now. So we
Okay.
just make that line go, and now I just
Right.
realized it's called the vertical one because it goes up and down,
Yep.
and the horizontal goes left and right.
Yep. Now, next thing is the horizontal asymptote.
Um, so where I just look at, okay, so that's where my question comes in, I guess, because I know like
The ratio
is it
of the
just
leading coefficients. It's the 1 over the 1. The one's in front of the x's.
oh, so that'll just be 1.
Y equals 1. So you can either go ahead and graph that. And so again, the
I
idea is that you're going to connect. something's going to connect. You don't know quite what yet. You might, the more you do these, you'll know, but you just sort of say, okay, I know I'm going to maybe connect these somehow,
Oh,
some way.
so
All
then
right. Next, I would find the x-intercept.
find the x-intercept. So then that would be taking the bottom and just adding it to 0. Wait, no, no, no. Take the top plus 0, which would make it shoot. I I don't know why this like just does not
Because
work.
because the reason is you're not remembering the rules. Like you set the
Oh,
top equal to 0. That's it. And solve for
yeah,
x.
it's like the top. So it's like literally just 0 because it's
You set the top equal to 0.
so then just x equals -1.
There you go.
Okay.
There's like four things to remember for what we've done for the horizontal, vertical, x-intercept, y-intercept. If you remember those things, it doesn't matter what they give you. It's the same instructions.
Oh,
It's like when you get in a new car, how do you turn the car on
you gotta like push the button.
or turn the key, depending on what it is, right? It's
Yeah.
doesn't matter what car you get in, it's got an ignition. Even the push button has an ignition. And then can you drive it or do you have to do something else?
Yeah, you gotta put it in a drive or
Got to put in,
reverse.
it doesn't matter whether you're driving a 1957 Corvette or a Tesla, right? Like it's got to get in the drive. It's gonna
Yeah.
happen, right? And if you want to stop the car, what's gonna happen? How do you do
You gotta
that?
push on the brakes.
Right. So that's what we're saying. It doesn't matter what you're in. These are the same rules. So if you can remember it that way, top equal to 0, bottom equal to 0, and so on and so on. So the y-intercept is when you're putting 0 in for x.
Mhm. 0 in for x.
Right?
So
Like
then that
I'm not telling you it's like the ratio of these numbers. I'm telling you just do this. It's
yeah.
kind of like saying find drive, whatever drive is in the car, you find it, you know.
Cool.
So
Yeah,
now,
that's a good analogy.
now this one has a little bit of a problem, right? Can you divide by 0?
No, you can't.
So this one does not have one. And sometimes they don't have y-intercepts. Sometimes they don't have x-intercepts.
Okay, so it's not like it can happen.
Yes.
All right. So then
All right. So now it's like, well, what do I
minus
connect? And the only point you really have is this one here. So it's like, well,
you
how can
just
I go
draw
from there?
one line.
Yeah, it's there, and then it's like, okay. Now some
And then
instructors want you
I
to,
still do I still mirror it like what you're doing right there?
yes, yes. Until told otherwise, yes.
Okay. So always have 2 lines unless told otherwise.
They're curves, but yes, they're gonna have one in each opposite diagonal quadrants.
Okay. Um so it's just the exact same pretty much just except less work
It
almost.
is, yeah, it actually is less work.
I kind of prefer the other way. I don't know why.
Well, I think because you did so many like that, there's a comfort. Um,
Just comfort and familiarity or whatever.
yeah, exactly. Yeah.
Okay. So just do that pretty much and then you're good to go. Because yeah, this is exactly what the quiz will be, is just one of these tables and a graph and convert using a common factor.
Yeah.
All right. Um so I guess like in general for these it's just same steps every time. They're not really that difficult. Always have 2 lines unless told otherwise and they'll mirror each other vertically
Yeah.
and horizontally, I guess. Or I guess reflect would be a better way to say it.
Yeah, of
And then, huh, okay. Maybe we can do one more and then
course.
maybe do a maybe like I don't know. I guess like a review for
All right.
finals. Like just do something easy, just brain refresh or something like that. Because I don't think
Okay.
we can
So
do the rest
here's
of
one
this.
more like yeah, I mean here's more one like your that you just got, but I mean, or do you want me to just make it more like what you heard?
Let's do one of the one we just did, and then one of the ones I'm more used to.
Okay. So let's just say it's one. Actually, we'll make this a little bit more good. Let's say it's two over x minus one. Two over x minus one.
F of x equals 2 of x minus 1. So then, I'm just gonna make it f of x equals 2 over x minus 1 over 1. And then I'm gonna multiply, no, add x to both of the 1, correct? Both of the ones?
You're multiplying the top and bottom by x.
Okay, that's what I meant to word it as. So then 1 parentheses x, 1 parentheses x, and then that would just be 2 over x. No, no, no. Yeah, actually 2 minus x over x. And then that's my final part for finding key features. No, 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 for converting. And then to find the key features, we know that we're looking for the vertical asymptote. So then that would be just make it equal to 0. So is that x minus 1 equals 0?
You're setting. I'm sorry. Do you have this as your combined form or
Yeah.
not? Okay. So you're setting the bottom equal to 0.
So just making the bottom 0. So x plus 0 equals 0, or
Sure. I mean, just be better. Just go x equals 0. Yeah.
all right, vertical asymptote. Oh, right, because they can be 0. I forgot. Yeah, that's my bad. Vertical 0, because x plus 0 equals 0. And then the horizontal, because you want to do horizontal after, correct? Or do you want to do end behavior?
Yeah. Give me the horizontal estimate. The end behavior is easy when you have the
Uh
graph. When you have the graph, you just basically say what happens over here, what happens over here. That's it.
uh
Oh, we should look at that next. But yeah, I was just hoping you give me the horizontal asymptote, x-intercept, and y-intercept.
So then the horizontal, I believe would be -1.
It's the ratio of the leading coefficients.
Uh,
You
well, I
said
mean,
you
it's
said
one
it's -1 over 1, which is
-1,
-1. All right. And
negative
then
one.
x-intercept.
The x-intercept is taking the top, making it go to 0. So then that'd be 2 minus x equals 0 minus x equals -2. X equals +2.
Okay. So 2
So
comma
then that'd
0.
be 2 comma 0, and then
And give me the
y
y-intercept.
would have to be, here, I'm just gonna write that out, 2, 0 and -2.
Uh, you're putting 0 in for x, so it's 2 minus 0 over 0. Can you divide by 0?
No,
All right.
you cannot, because it's
So
just x on the
there's none.
bottom. I did
Yeah, there's none.
so 0, 0.
Okay, so now let's put this into a graph if you can here. So we got the vertical asymptote at 0.
So that's up and down, and then the horizontal is -1. So then you just go left and right by 1
Yep,
below 0, 0 point, and then the x coordinate is 2 and 0, so you'd make that mark in, and then your y-intercept is 0, 0. Excuse me.
you got it. So now end behavior. So as x goes to infinity, f of x, as x goes to minus infinity, f of x, until further notice, these go to the horizontal asymptote, whatever that is. So in this case, it's going to be -1. That will change slightly when you work on some more difficult problems, but not for this ones.
Uh-huh. So let's see.
So that's what you should remember is that it goes to the horizontal asymptote, whatever that number is.
Uh-huh.
That's what it goes to.
So as x goes to the right, h horizontal hor asymptote
Yeah, the horizontal asymptote was -1. That's what it goes to.
goes to -1, and then as x goes to the left, it also goes to -1.
Yep.
So is it? Oh, okay, wait. So you're saying that because it's based off the vertical asymptote, so
No,
it's gonna be the same
it's
number.
based off the horizontal.
Based off the horizontal. So is it gonna be
Let's
the
go
same
back.
number twice every time?
Yeah. See
So
how this one
then,
approaches 1 on the right and then approaches 1 on the left.
uh,
That was the previous problem we did.
yeah,
The one before it approaches -4 and -4.
-4, -4. So okay, so that leaves me with a question, I guess, because the problem I did with my teacher for the domain, it's
That's different. Now you can't mix
oh,
things. Yeah. So
oh my
domain,
gosh, okay, wait, I thought you were talking about domain and range.
no. Domain is broken up by the horizontal, or I'm sorry, broken up by the vertical asymptote. It's typically minus infinity to the vertical asymptote to infinity.
Mhm.
Range is often, these are not absolute statements. It's broken up by the horizontal asymptote, minus infinity to the horizontal asymptote, union the horizontal asymptote to infinity.
So negative infinity, horizontal asymptote, and then, sorry, what's that U represent?
Union means or.
Oh, okay, or
It's used in set operators. That's domain and range are set operators or sets. So you have to use set operators to join sets way outside of scope of this course. So if you don't like it, just
no, it's all
don't
good, I'll
don't put
forgive you.
anything or just do it and just, figure out why later.
Um, okay, so negative infinity blank, boom, plus infinity. Okay, so then you do that. So are you using your vertical and horizontal asymptotes for
Yeah, you
that?
you have to replace those numbers. Like in this previous problem, instead of HA, you're gonna put -1. Instead of VA, you're gonna put 0. But these are always true in your problems.
Okay, all right.
So like in I mean to answer your question, yeah, in your problem, it's negative infinity to 0, union 0 to infinity, negative infinity to -1, union -1 to infinity. That's why it's
Mhm.
better to learn this sort of these like definitions and then you just apply them every single time for all the problems.
Okay. I guess that's true. All of this is just kind of copy and paste in a sense.
So like we should summarize these rules. Okay. The the vertical asymptote, you're setting the bottom equal to 0, solving for x. The horizontal asymptote right now is the ratio of the leading coefficients. So it's y equals, some number over number. But it's an equation. These are both equations.
Uh-huh.
It's not a number. It's not, you can't just say x, you can't just say 1. It's x equals 1, or you can't just say -1. No, it's y equals -1. They have to be equations.
Uh-huh.
X-intercept, numerator, top, or top, whatever you prefer, top equal to 0, solve for x. Y-intercept, putting 0 in for x. These are always, you know, these are always ordered pairs.
So ordered pairs. X-intercept number. So x0, 0, y.
And
So,
then end behavior, we just talked about. It's as x goes to infinity, f of x goes to the horizontal asymptote.
6 goes to infinity, if x goes to horizontal. So, are they both to horizontal or
Yep,
just because
yep,
HA?
yep. Because you've seen this over and over again. You know, it always approaches whatever
Oh, I guess
that,
that's true. It's always going left and right.
right. And then I already did domain and range. I guess I'll throw it in here one more time, but domain is broken up by the vertical asymptote. Again, these are not absolute statements. They work for the problems we've been doing. They do not work for everything. It
Uh-huh.
will it will work for your quiz tomorrow.
It will work for the quiz. All right.
I mean, I'm prognosticating a little bit, but that would be my best guess.
Mm-hmm. Shoot. Okay. Well, I didn't realize how much more in depth this little problem could get.
Yeah. And then graph as you go. Don't wait till the end.
Graph as you go. Don't wait till the end. You won't make mistakes. All right. Well, I guess that's kind of everything.
All right. We'll stop here for today.